Good morning, everybody. My name is Sergio Maffioletti from the University of Zurich. We'll expand a little bit and continue the presentation that Peter gave on the S3IT unit, the type of service portfolio that he's offering. And I will focus a little bit more on our cloud infrastructure. I'm not here to just convince you to do cloud. I'm not here to convince you to change anything with your own data center. I'm not here to sell anything, even though throughout the whole day I will be presenting quite a lot of tools. I just would like to share with you a little bit the experience that we gather in the last 18 months in running cloud infrastructure for supporting the research community within the university. We've been using those type of infrastructure also for serving research groups outside of the university, but I think we can collect some very useful information on how we can lever those type of infrastructure to provide a better support for the research groups. So my focus will be to share with you why at a certain point we decided to invest into infrastructure as a service. I think you're all familiar with the cloud terminology, so I probably don't have to give too many explanation of the differences between IaaS, PaaS, and SaaS has been already presented. I will take them for granted. But just have a very, very brief background. We've been operating certain type of infrastructure at the university, trying to provide services to various type of research groups. I come from the grid world. At the time, grid was the hype technology, and that was holding the promise of solving all the problems. And then we were offering a computational infrastructure to the research group. We tried to get engaged with those research groups, helping them solve some data processing and data analysis problem. Then at the time, we started to expand a little bit our scope. We tried to get engaged with the research group and try to understand what they fundamentally do in terms of type of research and daily use of the research infrastructure in a broader sense. We realized that indeed the requirements are much more variegated than having access to a single type of infrastructure. They need more integrated services that they can really use for their own daily operations and daily activities, rather than just a collection of infrastructural services. A computational cluster, which is what we were operating before, is just one of the components that they might need. They need specialized resources. They need integrated local storage, because of course they need also to store their data, but they also need to daily manipulate those type of data. So they need the storage to be available and to be performant at the same time. Great. Despite of the fact that I still try not to support this idea, and I'm still puzzled by this, but they do need specialized Windows machines. And they do require, more often than I thought and more often than we think, they do require access to Windows-based systems. They also need the possibility to attach the computational and storage infrastructure to their own instrument. This is a very common use case for those labs that are running microscopes and those type of instruments. Let's see what we have to deal with at the moment we started to discuss concretely with the research group and try to help them in a slightly broader sense. They need dedicated processing server. More often than we thought, researchers, they started to perform their computational research on their local machines, laptops, desktop, whatever they have in the lab. And they're fine with this as long as the laptop is powerful enough to do most of the data processing they need. At a certain point, of course, that's happening on a daily basis, that doesn't scale any longer. They need to expand a little bit, but the way they think is, my laptop is not big enough, please give me a bigger laptop, or please give me a bigger machine. They don't make the switch in, I need to move to another type of system to support my research. They're simply looking for a bigger machine. And this is the dedicated processing server. They really wish to have a larger machine dedicated for their own purposes that mimic exactly what they have on their own desktop to just run and analyze larger data as they did before. They wish to have customized environment because the way they want to do data analysis is, it can vary, it can require a lot of components and tools and services that are for their convenience, like running a central MySQL database for their own purposes, because they have some data processing pipeline that requires this. Try to bring this type of requirement to, allow me the term, to a classical HPC system is most of the time impossible. But this is a very convenient possibility for them. The community tools, this is happening more often, and probably this is an ongoing trend. Communities are somehow exchanging procedures, are exchanging tools, are exchanging services, and are investing a lot in making community services that can be reused within the community by other groups. Much more than before, at least to my experience, they are investing to make these community services more portable and more reliable. Not just the tiny little application that a PhD student has been writing for a few months and then suddenly should become a worldwide recognized software tool. But in this case, it means that there are some research group that comes to us and say, I've been doing this sabbatical research in another lab outside Switzerland, and we were using this data processing pipeline that works perfectly. Please make it available in our own local infrastructure. Or I've been attending a conference, and this guy and those guys are using those type of tools and those type of machinery that is completely not compatible with what we have in-house, but it would be best, it would be great if we could use it. We had a recent collaboration with the Functional Genomics Center. They wanted to try out a new platform for sequence analysis, genome sequence analysis. That was based on on Hadoop and Shark. They had very sophisticated requirements. It would have been pretty much impossible to just take everything and try to map it on a fully managed HPC system. Interactive windows. I will strangle every researcher that comes asking for a Windows server, but there are much more than we think. That they do need access to specialized Windows systems because some image processing applications exist only on Windows. Again, we use existing pipelines. They simply would like to take a pipeline that has been written for SunGrid engine or make assumptions on some very specific OS configurations because they only exist in RPM form or whatever. And they simply would like to have a mechanism to easily reuse this. At the same time, as many researchers are developing their own applications in MATLAB or in R or in wish they would use Python as well. Those type of tools comes with some, let's say, parallel processing libraries that should allow to use a larger computation distributed infrastructure for running this. And they simply wish to access this type of infrastructure from within those applications that they are writing. So using the MATLAB distributed computing toolbox, for example, or some extension to run parallel R, or running an IPython cluster. So accommodate all of these needs, it's complicated, but this is what we're there for to a certain extent. So we need to try to accommodate all of these type of requirements. And I really, really wish I could solve all of this with one single infrastructure. So don't be fooled. I'm not going to say that now cloud solves all the problems suddenly, but it helps. So since already 18 months, a little bit more, we're running a private cloud infrastructure at the University of Zurich, and we wanted to try out this type of infrastructure and see how we can accommodate all of these type of use cases in a single infrastructure and how far we can go with that. It's OpenStack based. We run it as an infrastructure as a service, but we don't offer this as an infrastructure as a service. We use it as our own tool in order to provide all type of support that the user needs. And I think that the important instrument, I'm giving you already the take-home message to a certain extent, from basically this year on, this is going to be one of the main instruments that the researchers at the University of Zurich will have in terms of computational infrastructure. So very, very quick history of it. We started in October 2012 with a test bed, running OpenStack on it, try the installation and see how it works and so on and so forth. And already in March, we decided to open to some research groups, some selected research group. We had a collaboration already with almost 25 users from almost 15 different research groups that wanted to try it out. And since then, the test bed, because at the end it was a test bed, has been also heavily used by some users as the sole research instrument for running their own data processing research. In October, we increased its capacity, so we inherited some boxes from the UZH. Thanks for that. And started this year, it enters into the production phase, and as Peter already announced, and I have a few additional comments at the end, we are planning to expand into this. So we decided, we basically realized that this is the direction that we would like to take to complement the HPC solution that we will be offering through CSCS as the research infrastructure available at the university. So this is not very interesting, but just to show that it's composed of very, very heterogeneous hardware of all the pieces that we could find around to a certain extent. Some we have purchased, some we have inherited from the UZH. It's heterogeneous in nature, let's put it this way, and I don't really think we will ever reach an homogeneity point. But how does this type of infrastructure help us to provide a better support to the research groups? Because ultimately this is all what this is all about. The application level integration, that gave us the possibility to go talk to the research groups, try to look at the code they're writing, sitting next to them, as Peter was describing before. We really literally sit next to them and ask them to show the code, and sometimes it's terrible code, but whatever, and try to understand what they are trying to do from the research perspective, how they map this research into actual development, actual application, and then we can intercept those type of needs, like I need to scale out a function within my MATLAB code, and I will wish to have the MATLAB DC at my running fast available somehow, and a relatively large cluster that can accommodate that. So we can provide on top of this infrastructure as a service some additional tool that simplifies the possibility for us to tell them, yes, you can use this infrastructure to launch your MATLAB distributed computing cluster and hook it up with your own function there. We can easily accommodate, easily it's a bold statement, we can easily accommodate workloads because we can create virtual cluster on demand with all the specs that the existing workload requires in terms of operating system, in terms of layout of the file system, if any, in terms of type of application that needs to be installed. Of course, that's normalized to the availability of the method that we do have. We no longer need, this is an interesting aspect, we no longer need a batch processing system to provide, to allow researchers to run their own data analysis research on this type of infrastructure unless it is needed. In certain cases, the batch system is extremely powerful because it allows you to have automatic orchestration of the resources. But in a cloud environment where you have this scalability, elasticity, or whatever they want to call it, feature, a batch system sometimes is not really the best model that suits certain type of data analysis part. So we don't really need to have a batch system all the time unless it's necessary, but we can use other tools, and this is a great level of flexibility in terms of how we then support those type of use cases. We have our own, but we also support others. And again, this is something that Peter also mentioned. We provide application integration, we provide support at the application integration level. We can look at the code they're writing and decide at certain point and which point the infrastructure should kick in. Before it was always like, I was running this, please give me a box that is big enough to support this application that I'm running. I don't know why, but it's requiring 128 gigs of memory. Now we have a slightly better flexibility in trying to look together with them what they're trying to do and plan the whole infrastructure accordingly, try to understand why on earth they are loading everything into memory. I know that this has pretty much nothing to do with the physical infrastructure as per se, but then having an infrastructure that can be very flexible in the way we can accommodate this, it's a great tool. Then how, continuing on the way we provide support, and in continuing the way this type of infrastructure helps us in the dedicated processing servers. When users want to have a bigger workstation, as they do have, they can, or they can be instructed to create their own virtual instance. They can create their own with the size they might need according to the availability. They can create their own volumes to put the data and decide the backup policy eventually on the data. They can attach it in there, have it run. It's a dedicated server, they run it. Of course, there are some support policies that comes with, but from the user perspective, it's also great. It's a great flexibility that you give them, the possibility to create their own larger toolbox. The customized environment and the community tools. This is probably a repetition, but it's very streamlined the way we can build from scratch or from some existing VMs the customized environment. In some cases, it's also interesting the fact that they do come with references to VMs or appliances that can eventually be downloaded from some other community repository, and then we can import them. Something that Peter mentioned, and I would like to stress it again. Of course, we are in the same, pretty much in the same realm as Amazon or Google or Microsoft Azure in terms of infrastructure as a service. We don't provide just infrastructure as a service. We complement this with our own support, and this is the added value. But at the same time, having this type of infrastructure that is compliant to a certain extent to the commercial provider allows us also already to think in terms of, can I or will I use an external provider to scale out certain type of use cases or certain type of application analysis. This is very important from us. And at the same time, I can also import to our own private infrastructure some community, some workloads that exist on commercial providers. Yeah. So what's next? As said, we're going to invest into this type of infrastructure. We're going to expand it. So in fall 2014, Peter probably you know better this. Not listening. In fall 2014, we will purchase. There will be the public procurement for extending the infrastructure, and in 2015 we will integrate the existing testbed with what is going to be purchased and the. Yeah. Okay. You wish. We're already in summer. And the repurposing of the Schrödinger. So we are aiming to reach something on the range of 100 teraflops. So it's relatively small still, but that should be the first step toward an ever-growing infrastructure. So that's pretty much everything I wanted to tell. Thank you very much for your attention. I was very fast, and so if you have any question.